Given y equals negative x to the fourth plus 4x to the second plus x, find the end behavior. That's how the graph acts at the far left, and the far right of the graph. It doesn't say what's happening in between. To identify the behavior at the end, we're going to first consider the degree of the polynomial. The degree, which I call n, is equal to 4. It's the highest power on the variable x. So that means 4 is an even number, so it has an even degree. Also, we need to identify the lead coefficient. That's the number multiplying the highest power of x. So the number that's multiplying x to the fourth is -1. That is a negative lead coefficient. When you have an even degree with a negative lead coefficient, that means you have both ends pointing downward. You notice we don't have any idea what's going on in between, but boy, those left and right extremes are pointing downward. Now, how would you write this in an equation or in an expression instead of a picture? You would say that y is approaching negative infinity as x approaches negative infinity. That describes the left side. To describe the right side, we say also y is approaching negative infinity as the x values are approaching positive infinity. See, as we move to the right, that describes the right side. Now, if you take the graphing calculator online and you plug this equation in there, you can check to see if you have this type of end behavior when you do the actual graph using the calculator. So we're going to do the y-axis and the x-axis and run this through the online calculator, and we're going to get the golden arches. But the point being that the left end goes down and the right end goes down. So yes, it does verify that our answer is correct. In an exam, you couldn't just whip it out that fast. You just have to answer depending on the degree of the polynomial and the positiveness or negativeness of the lead coefficient.